Hi, mathematicians. In this video, we're going to learn how to factor a quadratic, how to convert a sum of monomials into a product of binomials. To get started, we're going to start with the simplest version of a quadratic, and that's one where our a, the number being multiplied by x squared, is 1. So here we're talking about a simpler problem where a is 1. What we're going to do is we're going to start by multiplying two binomials, something you know how to do, and then use what we learned to work backwards to factor. So let's get started. We are going to be multiplying the two binomials, x plus 5 times x plus 2. I'm going to use an area model, and I know you know how to do this, but let's really think carefully about what we're doing so we will know how to do it backwards, how to work backwards. For my area model, one side is x plus 5, and the other is x plus 2. I'm going to fill in my squares, x squared, 5x, 2x, and 10. Let's collect now those terms. If you did the double distributive property, you'd also get here x squared plus 5x plus 2x plus 10. Finally, simplify by combining those like terms. Notice they're coming up here on the diagonal. Let's combine those like terms, x squared plus 7x plus 10. Now let's dig a little bit deeper into what we were doing and seeing connections between the factored form and our quadratic in standard form down here. Notice that the two constants, 5 and 2. To get 10, it was 5 times 2. And to get 7x, where b is equal to 7, it was 5 plus 2. Interesting. Is this reminding you of anything about finding two numbers whose product is one thing and whose sum is something else? All right, so now that we see a little bit more about working forwards, distributing, multiplying two binomials, let's do the same thing but backwards. So to factor, I'm going to start with my quadratic in standard form, and I need to figure out how to turn it into binomials. Again, I'm going to use an area model to get a good visual picture. But now I can only fill the inside of my area model. I know I'm going to have an x squared here, so there'll be x times x, and I'll have a 10 here. Now I have a problem because I don't know how to split that middle term 7 into the right two combinations. Is it 1x times 6x? Is it minus 8x plus positive 15x? What is it? So that's my big dilemma. What will these two like terms be that I'm going to add together to be my like terms? Now I know whatever they are, when I add them together, they have to equal 7x. But I also know I'm going to need two numbers that multiply together to get 10. It's a diamond puzzle. Let's make a diamond puzzle. Two numbers multiply together to be 10, add together to be 7, and I know those numbers are 5 and 2. So that tells me those two numbers, 5 and 2, they are the side lengths, because we know 2 times 5 is 10. We'd have 2x here and 5x there, and I know that those two things add together to be 7x. That tells me now that this factors into x plus 2 times x plus 5. We need to define two numbers, add together to be 7, b, multiply together to be 10, c. Let's now generalize this big idea. The big idea that we have here was a quadratic in standard form, and it's equal to this same quadratic, but in factored form. We're able to turn addition of monomials into multiplication of binomials. And the big idea is to factor this with a equal to 1. You really just need to find two numbers, and those two numbers have a sum of b and a product of C. Let's add a little diamond puzzle to help visualize that. We're looking for two numbers whose product is C and sum is B. We might just call those two numbers N and M. They can be anything you want. And I know that N times M must equal C. Remember, that's my constant. And N plus M must equal B, the middle term, B and C. Once we know that information, then we can factor x squared plus bx plus c. It becomes the two binomials x plus n times x plus m. Sorry, I ran out of room there. All right, so it's time for you to do a little factoring for yourself. Let's go.